Yeah, go ahead, sir. Yes, Andre.
If I feel like I'm about to say something bad, can I tell you that F1? F10.
Say that again.
Because it says F10 stops recording, right?
You are smart.
I was like,
You're very, see, I know. Yeah,
like if
I
I'm
know
about to
that.
say something,
Where
just
did
yell
the
F10.
autograph? No. Yes, this autograph will be worth something very. Yeah,
Starting a legacy, bro.
yeah. You very good.
Microphone.
Thank you so much, Andre. Okay, all right. So that's okay. Don't break anything. Your calculator. All right, good. Okay. Now, excuse me. So, and see, it's blinking, so it will. Okay. So what we are going to do is section 6.2. That's what the professor wanted us to do today, right? Okay. What is section 6.2? What is that? That is about somebody, anybody? Normal distributions, right? Okay. Now, what are normal distributions? Normal distribution is a specific kind of bell curve. Everybody fine with what I mean by bell curve? We are in call, so this kind of curve, as I'm just saying by waving my hands, right? Okay. So, and of course, in real data, something that approximate to bell curve in a certain way. I'll tell you what do I mean by in a certain way. Okay. So, like, see this here, I have some data here for you. This one is like, about a bunch of people took a test, okay? Is that clear? And the data that you see in this column is the time that they took before they deposited the test. Everybody fine? Okay. So let me show you a graph of this. Everybody knows what histogram is. I subbed for professor before. Oh, no, not that, no. I subbed for professor before, and I saw you all know histogram pretty good. Okay, time take. Okay, so this is, do you agree this is kind of a bell-shaped distribution, approximately? Yeah, I said approximately, right? So there was one disagreement. Looks like that disagreement is no longer there, right? Everybody fine?
Yep.
Okay. So this was, now here is a wait time, for a call, like when you call for some technical help or something else, okay, and you hear this, that is, well, your call will be answered in approximately 10 minutes. Does anybody have an experience like that, or, right? And sometimes it's answered before, right? Isn't it? But if it goes after 10 minutes, sometimes it takes for what? For forever. Have you experienced that? Oh, well, you Andre experienced it all the time. I experienced it sometimes, right? Okay, so yes, but it does happen, right? Okay, so if I look at that, then what will happen here? Does this look like a bell-shaped distribution? No, right? And there are many in between. I mean, this is, of course, a very, very heavy departure from bell-shaped or symmetry, right? Okay, so, but there are many things in between, okay? So, as I said, the bell-shaped distribution, okay, a bell-shaped distribution that satisfies this equation that we were looking at. You don't have to know this expression. If you took algebra 2, you might have good memories of exponential, right? So it's just formed with exponential. So that's what gives us a bell-shaped distribution. Everybody fine so far? Okay. And the reason it's called normal, it's not that normal means this is what normally should happen, okay? Don't take it for granted like that, because this is more like a historical term. Statistics has been in practice for centuries. So earlier what happened was scientists would think it's a mathematical fact, mathematicians will think it's a scientific fact, okay, that everything should have a normal distribution. But now we know many things don't have a normal distribution, and I'll show you an example. All right, so far so good? Okay, so say for instance we are looking at a normal distribution, okay, that has a mean of 90 and a standard deviation of say 10. Okay, how it would look like, and I'm doing it by machine because I want to show you this like nicely sketched, and I also want to get a video for you. Does this look like a normal distribution? Does it? Yes or no? No, it doesn't look like that to me, right? And I said it's going to be normal distributions. Kind of embarrassment, isn't it, right? So tell me, what should I adjust? Its mean is 90. Do you even see 90 anywhere in here? No. Okay, Andre, wake up. And this is the standard deviation, right? Okay. So what I'm going to do is that I'm going to adjust the window, okay, pretty soon. All right, so let me just do it like this. What was the standard deviation? It was 10, right? So 52, let me just make it like 130. So here you go. Does it look like a bell-shaped distribution now? It does, right? The mean is 90, and once you go like 30 down, means up to 60, right? 30 up, that is 120. Everybody, clear on up and down the way I'm saying, right? Almost everything is gone, right? Everybody fine? Now, let me take another normal distribution. Say I take this normal distribution that we are going to take in the example. Let me bring it up for you because I already opened it. Okay. All right, spring and subbing. Here you go. What is that? Yes. So here is this. That say we know that the heights of adult males, they show a normal distribution with mean 69 inches and a standard deviation 2.7 inches. All right. So Henry, say we have this information, and you will know very soon how to estimate this information, right? Everybody clear? Okay. So if I want to, and this was regarding time. Okay. So let me do this here. Let me, in that one, what we had, one sec. What was the mean? 69, right? And this is 2.7, and you can see these parameters. It's very important to know these parameters, right? I mean, if you're designing clothes, if you're doing this, designing beds, and lots of places, doors and all those things. So you will have to do that. And in here, you can see we don't see anything. So we will adjust these scales, okay? So 1 second. So 69, let me go 59 through 79, right? Okay. You can see we have a different looking normal distribution, don't we, right? Everybody fine? Okay. Now, one thing is like kind of slightly an illusion here. That is, you see that this curve touches the axis of x, but in fact it does not. All right, everybody fine? It's do you remember asymptotes from algebra 2? Yes or no? Okay, so the two are like asymptotic. So one sec, my computer is slow. I need a new one soon. Okay, here we go. Everybody fine? Okay, so here we are. Okay. Right, so here we have everything, right? Okay, good. Oops, that was not good. Everybody fine? Now, so we have a normal distribution, right? Tell me this. That this is what, 69, right? So if we go according to this, then what percentage of people are shorter than 69 inches? What percentage? Yeah. 50%, right? Everybody clear? Okay. Now, say I did this. I asked you this question. What percentage of people are shorter than 66 inches?
25.
Louder.
25.
How did we get 25? It's very good, Rebecca. I mean, you looked at that, right? And it looks like approximately it's 25%. But are you as confident about that 25% as you were about 50%? Say yes or no? No, right? Okay. So what we can do is, in your book, there is a table called Table A. All right? A as in apple. Everybody fine? I don't think many of you brought your book today. Did anybody bring it? Oh, many of you did. Oh, I was wrong, right? Okay. So look at Table A. All right? And since I didn't bring the book, or I would do this, that I would...
You want to use mine to put on the show?
Oh, actually, thank you so much, Andre, but I don't need to right now, okay? Why? Because, see, this here I have created this table myself, okay? All right? But I'm just saying the table that I'm showing you is the same kind of thing as Table A is. Everybody clear on this? Right? Okay, thank you. So far, so good. Any questions? Any questions for me? I don't know. You have the book. I don't even have the book in front of me. Okay. Let's see what page. Okay. Let's do this here. We'll find the page when we are looking for this table, which is Table A. But as I said, don't worry. Let's use this one. This and Table A are identical, almost identical. Okay. Almost, yeah. But that almost is not a trick or anything on there. There's just like, okay. Everybody fine? Okay. So see, what we are going to do is, give me, yeah, just pay attention. I'm not saying close the book. No. It's a book, expensive book, right? But what we are going to do is we are going to see the standardizing normally distributed variable. Everybody clear? That's what we are going to see. We are going to talk about standard score, okay? And still, like, when you go in your employment and you are in meetings, you will still have some traditional people like me who will say, oh, the standard score is very high in this case, all right? So typically, or generally, what people mean by standard score is that you take the particular value, whichever value you have, right? Everybody fine? What you do is you subtract the mean, and this is a symbol for mean. If I do not write mean in English, is that okay? Mm-hmm. All right. And you divide it by the standard deviation. This is the standard score. Is that good? Mm-hmm. Okay. So this is the standard score of X. Everybody fine? Am I making sense? Mm-hmm. Okay, good. The standard score of. Now let's go to our previous question. That is, remember this? We wanted to know that what percentage of that reference population consists of people who are shorter than how many? 66 inches, right? Everybody fine? Okay. So for that, what you can do is this, that you can compute the z-score for 66 inches, okay? So if I'm looking at, say, x equals, okay, 66 inches, how would I work on this? We have x equals 66 inches, right? Everybody fine? So let's write x equals 66 inches. Okay. Oh no, not you. Excuse me. So we have 66 inches. All right. And what's the mean here? Somebody, anybody, help? What's the mean here?
69.
Okay, 69. Very nice. We don't have to keep on saying inches and inches, but the thing is, I am writing it because it will show us some use in a moment. Okay. So then what happens? We will have 2.7 inches on the bottom, right? Everybody fine? Mm-hmm. Okay, and then I'll use my calculator just to get it quickly, right? Okay. All right, so just give me a second. My calculator is coming up. It's right here. Okay, good. All right. So, Jennifer, why don't you? Yeah, Andre, sir. Question.
Can we hit that 10?
Huh?
I might ask something stupid. Can we hit that 10, please?
What did you say?
I don't want to sound stupid. Can we hit that 10?
I didn't hear you. What did you say?
I don't want to say something stupid. Can we hit F10?
I'll hit F10. Oh, sure. Okay. So you all know where 66 came from. It was just a question that we were curious about, right? So what happens is if you did this, okay, let me make this calculator is a little smaller here. Okay. All right. So we have 66 minus 69, right? And divided by 2.7. That's the z-score, right? So how much z came out to be then? It's like about, excuse me, it's about negative 1.11. Can I say inches here? No, it's unitless, right? Everybody clear? So what happens, what we did was we transformed it in terms of a particular normal distribution, all right? And which is called standard normal distribution. Everybody fine? Gee, am I making sense? Okay. And what does a standard normal distribution have? A standard normal is of course normal distribution with mean 0 and standard deviation how much? 1. Okay, it says just a standard normal distribution. Remember, I was using this to sketch all these bell curves. So this is a specific bell curve that the book uses a lot, and depends on Professor Pippin how would she do it. So that thing is, so this is the mean is what? 0, right? Makes sense? And you can see it like almost flattens out when we go up to +3, and on the right side it's almost gone by the time you're a little to the left of -3. Everybody fine? Makes sense? Okay. So this is standard normal distribution. So the question is, what does the table A do? Okay. So the table A does the following. Leonardo, may I have your help, please? Okay. So say this is table 1, right? Makes sense? No. What table is that? Table A, right? Okay. Now, remember our z-score was what? -1.11, right? So these guys here, I forgot to write a z here. Okay. These stand for z, this column and this row. Am I making sense? Right? Okay. So what happens here is this, that is, one sec please. So remember, our point of interest here is who? Z equals -1.11, right? Am I making sense? So what do we do is this, that see here I have -1.1. Everybody with me? Mm-hmm. So I'll go to the right, What's the number on the top there? 0. So that's negative 1.10. Makes sense? Go further. What's the number on the top there? 0.01. So that's negative 1. That corresponds to negative 1.11, right? Everybody fine? Okay. Now I have to wake me up, right? Oh, that's all right. You can relax. So the thing is this. So see, this number comes out to be number of... No, what happened here? The bulb is out, so I have to be quiet. Okay, I have to hit F. Okay, good. Okay, so see, what we have is this. This number is 1.335, right? Okay, so what it simply means is this, that the area, okay, if I did this, if I say brought it in there, that the area to the left of negative 1.11 is how much? 0.1335. Everybody clear? That means about 13.35% of the values are below negative 1.11, right? Is that fine? Okay, makes sense? Okay, what about Olga? You look puzzled. Am I making sense? See, that's what it means. In the table, this is negative 1.1. This is 0.01 here. So this number here in the table corresponds to z equals what? Negative 1.11. Okay? And this number simply means that the tail to the left of this is 0.1335, which is proportion, okay? And when you change this proportion to percentage, everybody clear? When you change this proportion to percentage, then what happens? Then in that case, it will be 13.35%. Am I making sense to everyone? Right? Good. So look here, Rebecca, our guess became wrong, right? Because when we looked at the area corresponding to this, I forgot so quickly, can't believe it. That turned out to be what, how much? 0.35%, right? So about 13% of the people have what? Heights in between, sorry, heights shorter than, people means adult males have heights shorter than that, right? Am I clear? So let me ask you another question very quickly. Let's have this, because I just want to be quiet in like 5 minutes. I'll take you to the calculator and all that. Okay, so here, I'm giving you this, that here is, say, temperature in a region, okay, where varies, I'm saying normally, which means normal distribution, right? Okay, with mean of, say, 4 degrees, come on, Celsius, okay? Everybody clear? And standard deviation, okay, say 25 degrees Celsius, all right? So say we know that, right? Everybody clear? So what I would do is I would like to graph this guy, right? And we know it's a very cold region. Everybody clear? That it looks like a very cold region. Okay, that's all right, because it doesn't happen here, so we are okay, right? Say that. What happened, Andre?
No, I was just saying that I was naming areas.
I didn't hear you. Sorry. That's okay, but okay. Okay. Okay, just a second. Let me just do this here. Negative 100 to 100. So it may not be on the earth, and I don't mean a region means region on our earth. Okay, it could be a region anywhere, right? All right, and those of you who watch, you know, that is. And so anyways, so here is the situation, right? Everybody clear? Okay, good. So you tell me this very quickly. Okay, here. Okay, let me get another one here. I'm asking you a question and you try answering it. Okay. Say I asked you this, what is the probability, all right, that the temperature will be below, okay, say, yeah, why don't you pick a number? What are you interested in knowing? What's a comfortable temperature for you? Negative 15, sure. Negative 15, I know, negative 15. Okay, degrees Celsius, right? Everybody clear? So how would we do that? Yeah, tell me very quickly, somebody, anybody? Z-score, very nice. I forgot your name. Could you say that, please? Jacob, right? Okay, thank you, Jacob. So we'll get the Z-score, and since we have the calculator, where did my calculator go? Right here. We'll go for the Z-score. So how do I get the Z-score?
0 minus 15.
No, wait. Negative 15 is the value of x, right?
Okay, negative 15 minus 0.
Not 0. 4 was the average there. That's okay. I mean, I took that number away. What was the mean?
Wait, why does it say 0 then?
Where did I say? Oh, I see. Okay. Yeah, it looks like 0 because what happens is this. Yeah, it's the scale. See the top here? That's about 4, right?
Can we scale it by 5
Say,
to make it easier?
say that again? We can, yeah, sure. But why would you do that? You got this calculator working for you, Andre. Oh, you may do that. You may do anything. That.
It clearly just caused confusion. You know?
What did he say? I'll hear later. No, I'll simulate and hear it. Okay,
No,
Andre?
I'm saying because it caused little confusion.
I know it did cause confusion. Yes.
I think
Yeah, but we are learned people. We got unconfused very fast, right? Didn't we? Right? Everybody fine? So what's the Z-score? Okay. What's the Z-score? Why did I take the calculator away?
Negative 0.76.
Thank you. So Z equals negative 0.76, right? Everybody fine? So let's go to the Z table. Okay. And I said, don't worry about noting it down. You can stop it, rewinding, or do whatever. I'll post it before I leave the room unless internet goes out at me. Okay. So tell me this. Look at this here. What was that? Negative 7.6, right? So what number do we see? Negative 0.7 here. Does everybody see that here? Okay, let me just do this here. How do I? Well, that's hiding there below the desk. But is okay. I know Gia and Olga and Derek. Can you guys see below there? Because that's below the no. So I will do this. Don't worry. I have a suggest solution, a negative 0.76. Don't worry, I'll bring it up for you. Okay. All right, come on here. Okay, can you see it now? Can you see it now? Right? Everybody can say it? Right? So what I would do is that I would go from negative 0.7. Everybody fine? And I'm going to stop at where? Right here at 6, right? Is that good? So what does it say? Probability is what? Like 0.2236, right? Am I making sense? Okay. So the answer to our question is, if I can find where my question is, okay. So again, that's crazy. I forgot the number. Right? Okay, so let me take the number.
So are we going to get one of those charts?
so, but the thing is this, you know what? You will not need it. Let me just show you in one moment. You are not going to need this chart, okay? So the answer is this. Everybody fine on this? Okay. So let me tell you, yes, sir.
I just want, how do we get the standard deviation from the information?
It was,
we have?
Use your calculator.
So you got to enter the
You
little
put it in
list.
the list, and then you go to stat,
Right.
and then you go to calc, and then you press.
very
plus
good. See
stat.
what Rebecca is doing is she's,
What information did you put in?
I'm going to show it to you, Andre. She just took my job over, which is very good. Thanks. And this is the last thing I'm going to say. Then I'm going to be quiet. Okay. All right. So here. So this is point. So let me just tell you what Rebecca was teaching to Andre. Okay. So 1 second. Okay. So you will do this. That you have the calculator, right? Everybody fine? This is kind of the calculator that we have, right? So one way is this, you go to second distribution, right? Am I clear? And for this purpose, what we can do is we can use the normal CDF, okay? Am I making sense? Okay. So you use your normal CDF. Now, very quickly, let me tell you what does the normal CDF want you to, no, not that, wants you to do. It does this. So when you have the normal CDF, then it wants that, what is the lowest number in your range? Everybody clear? Okay. What is the largest number in your range? Everybody clear? Then what is the mean? And what is the standard deviation? Everybody fine? Okay. So that's what it wants you to. That's what it wants from you. So let me get the calculator and tell me this. What's the lowest number in this range? Louder. Somebody, what's the lowest number? If I keep on going to the... No, 0 is down here, Rebecca.
Oh, negative 60.
Well, we can get further, right?
Negative 70.
Or negative 10 to the 100, which is negative Google, right? Everybody clear? That's what Google is.
Infinity.
Say that again?
Negative infinity.
Yeah, but I can't handle infinity in my hand, right? So let's just...
Negative Google plus.
We'll just go negative Google minus, right?
That's bigger.
Okay, we will do this. Okay, so let's just do this here. So see, this is the smallest negative number that your calculator can handle. Everybody fine? What was that? Negative 10 to the 99, okay? And the largest positive number that it can handle is positive 10 to the 99. Everybody fine? Okay? So you do this. This is the smallest. Then the largest point that you had was what? Negative 15, right? Am I making sense?
What? I thought you said it was 10 to the 99.
Well,
No, that's the largest.
look here. What you wanted to do. Oops, where did the calculator go? I lost it.
Oh, it's the largest because it's asking what's the average will be below that number.
What percentage is below that number? So you want it to be
So
at.
that's the high. I get it now.
You get it now. And what was the mean? What was the mean, Julia? What was the mean now? Mean was
4.
not 0, 4, right? Yeah, very good. Mean is 4. It's not going to matter much if you know. And what's the standard deviation? Anybody? 25, right? So if we did that, did we get...
You gave us the standard deviation earlier.
Say that again?
You gave us the
I gave you this.
Oh, that's
Right.
They're going to give you a list and ask you.
Okay.
that's what I was.
So everybody sees we got the same answer. Actually, we got a better answer, right? Am I making sense? So let me hit F10.